Well, hello everyone, welcome back. I see a lot of familiar faces, is always good, and a lot of new faces, which is also good. My name is ECE3551. I'll be your instructor for this course. You can call me Dr. Z, hey, or Saide, or Dr. Z3551. I'll respond to all of that. This is Brett. Brett, you want to introduce yourself?
Yeah, hi everyone, my name is Brett. I'll be your TA this semester. Hope you all had a good winter break, and I'm looking forward to the semester.
All right, so today I will talk about how the course works. If you have had class with me, you know how I work, how I manage my classrooms. If not, today should be a good session. I am recording all of my classes, regardless of the university policies, but note that this is supplement. So sometimes I walk around and the Zoom might not capture my voice properly. So that has happened before. If you're watching the videos later to work on the assignments or homework and you had questions, my voice was not clear, ask me or Brad to help you to figure that part out. We will have a discussion boards for class discussion. Brad is also setting up our Discord. So you could use Discord during the classroom to ask your questions. During the break time that I will give, you can talk to each other, share your pet pictures. I will do Pepper and Cocoa, I'll show you. Hobbies or anything. So kind of a community that we want to build on, but out of class topic only when I give you break. But since we all wearing masks, if you ask a question, I might not understand the question properly, you can type it in the Discord, which Brett is monitoring the whole time. I will give breaks and he will either answer you directly, or if he couldn't, he will ask me to answer. You could also raise your hand, and if your voice is loud enough like me, then I will probably hear your questions. And you can also use Carmen discussion board. Some of you, like last semester, they said they didn't like Discord. You could also use Carmen discussion board. We are not checking that through the class, but I will check that through the week, and especially when the homework comes along, I will check discussion board more frequently to help you with the questions. All right, so feel free to ask questions. Email me, email Brad, use office hours. We will decide about office hours later, but you should ask all the questions. There's no stupid questions, right? But if you don't ask the question, then you cannot expect us to help you solve it, right? So don't assume anything. All right. So a little bit of introduction about myself if you don't know me. I'm a senior lecturer at ECE department. I teach Introduction to Robotics. I teach this course, Feedback Control. I teach technical writing. Many of you had technical writing with me. I teach capstone 1 and 2 now, and I have taught circuits for non-believers to ME students. So any of those, if you have questions, you can always approach me. I'm also the advisor of the underwater robotic team and faculty of record for the first mentorship program that we have at Ohio State. So I can take classes and help the first teams in high schools for competition and whatnot. I really like control, so I would say this is the most interesting field for me. My PhD was in controlling of underwater vehicle and linear and nonlinear control. So sometimes I get very excited and I talk really fast. So be aware, ask questions. If I skim through something really fast, you can ask me to slow down or explain that topic better. So the goal is to give you an intuition to understand what control is and how to approach a system and how to analyze it. So I think, in my opinion, control is part of our life because there are systems all around us, and we are at some point we are controlling that system, we are using that system, we are manipulating that system, right? It could be from eating food, sleeping, driving, your car cruise control. Lucas mentioned the fridge, that your temperature control, or the AC, anything you can think of, you can find some sort of system. If you have a system, you're controlling something. So you're manipulating a state of something. In this course, we are going to focus on CISO system, single input, single output. So I will talk about multiple input and multiple output system, but all the assignment, everything will focus on one input, one output, one output. And that just means this problem is more simple because you only have to deal with one thing and control one input. Is it coming from my computer? Okay, from your computer. All right, so how this course works. This class is in person, and as you can tell, I will record all the material. Unfortunately, due to COVID, we might lose some of the classmates for 2 weeks. So I have let just now that connect to Zoom. I'm not planning on doing that because I know sometimes you just don't want to come to the class, you think they can come to the Zoom. That's not me being mean. I think, especially this class, being in the classroom, participating in the conversation and the discussion is really important for you to understand. The learning has to happen in the classroom. If you had robotic with me, you know how it works. And if not, you will see. We do a lot of class participation, class activities, and you actually use what you have learned in the small activities in the classroom. So being over in the Zoom would not help much. You can always watch the recording afterward, which I will provide you. All right. So if you get sick or something, you don't have to attend the Zoom. You just have to watch the videos after, but you have to do all the assignments. So if you are missing the class, it is your responsibility to do the assignment. Now, most of my class participation requires some sort of passcode, right? So if you are missing the class, you have to email me and ask the passcode. If you are meeting 3 times a week and you're off that week, you have to email me 3 times for each individual passcode. All right. So that way I can see if you miss the class, it's fine. Right. So I will drop some of the class participation at the end, but I think if you look at the syllabus, we have like 28 class participation. So if they're all 10 points, let's say, and you have what 20%, 15% of your grade for class participation, it's going to be a really small amount. So you can do the math and say, okay, I can miss this many class participation and nothing will happen. Make sense? All right. Hopefully you don't have to miss. If you check the syllabus, you'll see we have 4 homeworks only because I greatly rely on the class participation question. Those are really good conceptual questions. And in your exam, when you're studying, you have to study the class participation as well. It's not just the homeworks. Homeworks are problems that are bigger and you can do outside of classroom. All right. I talked about all of this. Any questions so far on what I said? Clear? Thank you. All right, so we will have 2 exams and 1 final. I might give you a small project to deload the final of the problems. So it might be just some conceptual question. I haven't decided yet, but I reserve the right for myself to have a final exam and maybe a project. All right, so depending on the class performance, we can decide as we go, but if you need to plan on having a final exam. All right, and the date would be based on the university assigned dates, which we will know later on. We both will have office hours in person and virtually. I will try to have a specific virtual office hours because in my last classes, whenever I have in person, when I'm talking to someone, I'm not paying attention to my Zoom. So student comes in and out because they can't just come in to my office. They have to wait. I don't see it. You have a class, you have to leave. So I'm going to have specific virtual also if you need, or if you are planning to meet with me, not in person and virtually, email me before. So I would expect you. That way I can let you in. All right. So both of us trying to help you with your question. I know that the first few weeks we probably won't use the office hours, but as we go forward, I think it will be more. It's also good to just come and talk. And so we know you better. It helps a lot that both of us know you on maybe a more personal level. All right. Communicate with me through Carmen Discord, which we will set up later. And my email is yaifad.1@osu.edu. If you type just yaifad.1 and click when you're sending an email, it will create a bakaimail.osu. I don't have that email, so I would never see your email. So make sure you type out actually the whole thing, because it has happened. Student missed the deadline because they sent the wrong email. I've never seen it. And if I don't see it, then I can't grant them what they asked for. All right. I will update Brett's information on Carmen on the first page for you if you needed to contact him. Grading and assignment. So this is probably the most important part of this today's class. Class participation and quizzes, 20% of your grade, right? When I say quizzes, is not big, small, simple question that reflect your understanding of classroom. You can miss a few. Mostly graded based on correctness. Sometimes we just grade based of completeness. We'll let you know. All right. Homework 25 and the exam. So homeworks are individual unless we tell you it is group. Usually is not group in this class. For this class, this class heavily relies on MATLAB. So if you forgot, you need to brush on your MATLAB skills. Please do so. I will have lectures that we only talk about MATLAB, and I will tell you all the command you need for control, right? But I expect you to know how to write a program or piece of code and file, how to plot something, how to change the axes so we know what X and Y axes are, right? If you forgot that, I will post a 101 MATLAB that has all these basic in it, but it's on you to catch up, all right? The days that we are using MATLAB, you can use MATLAB online. So I'm expecting everyone to have iPad. Does anybody not have iPad? Okay. They told me that you should all have iPad. All right. But you can sit next to someone that has and you can work with them. All right. Or you can use your computer. Yes. So you'll see that in the module, I will tell you what we're talking each day. So you would know what we will be doing during the week in advance. So you can prepare and bring your digital device for those days so you can actually follow and type the commands. And MATLAB online is great for quick things. For bigger programming, you might need to use actual computer that has MATLAB on it, especially when you're using Simulink. We're going to also get to Simulink. What else? If you're missing a class due to COVID or not due to COVID, you have to tell me. You have to inform me in advance. Then that way I can excuse you for the class from the class participation. If it's a few times, 1, 2, 3 times. If it's COVID, we need to have a arrangement how to deal with your absence, because you will miss all the codes. You have to ask for it. So make sure to let me in advance. Things also happens in life. You have to communicate with me. If you miss a deadline, it's lost. You get a 0. You just have to catch up for the next one. All right. It's kind of a zero tolerant policy. All right. Then I do not check my email. Any questions so far on these things? Very good student. I like it. Don't have questions. All right. So can everybody go and check this page, your Carmen page, if you haven't already? If you have your phone, you can check through your phone, it's fine. You can use your phone for past assignments. Sometimes quizzes are easy to do on the phone. Since most of the submissions are PDF, you can also take a picture, use Cam Scanner, convert to PDF, submit. So all the material will be provided to you on this page. All right. So make sure that you're familiar. If you haven't had class with me, you want to make sure that you know how things work. Well, I'm not going to move because I want to record. So this side is the navigation bar. You'll see that for you, it might look different. I think this is actually student view. I only activated a few. So you won't see all, like you don't see files, you don't see pages, because I don't think it's necessary. I have arranged them for you in weekly basis. And once you start using, you'll get used to it and you know where to find the information. So you want to make sure that you explore that a little bit this first week. Here, you see all of my assignment have dates, due dates. So you see all your to-dos on the right side. And you can also see all the announcement up here. And if you go back to, if you go inside, well, if you click modules, then you go to this page. You'll see that the course is structured as weekly module. So every week you will see an overview. So if you don't have time, let's say Sunday night, you have so much on your plate, you just want to know what's going to happen next week. Go to overview and you see how many assignments you have to do, what are the deadlines. So that's a quick 2-minute overview for you. All right. Some weeks are lighter, some weeks are heavier. So you can kind of figure out that with your schedule. So you have 4 places to access your assignments. 1 is that homepage. 2 is on the navigation where you see assignment and quizzes. 3 is in each week's module, which is here. Well, which is here. Here. Then you see all the assignments. You also, if you go to syllabus, you'll also see at the bottom, you'll see all the assignments, right? But I think from my point of view, it's easier to go through the week so you know what you have for the week. All the assignments have deadline, due dates. If you know at the beginning of the week something is happening, you have to go to career fair. You have a conference in another city. You are part of the a team that you know that you have a competition, you know all the dates, right? You have to tell me before. Don't leave it for one day. That one day notice is not advance notice. I will usually tell you a week before what your assignments are. The reason I'm focusing so much on this in this class is once we're done from Wednesday, no late assignment will be accepted because it's kind of a contract, right? So this is the most important part of this contract for me. You're 60 of you and I have other classes. So if you miss something, this gentleman has to find a time in his schedule to grade, right? And he's a graduate student, so you don't want to do that to him. All right. Every lecture has a unique page. So now if you click on here, today we are 110. So you see it's dated. If you click on that, it takes you here. You see that I will post a blank slides before the class. So you can follow on your iPad if you need to write. I will post an annotated version after the class. So if you don't like to take note, you need to listen, it's fine. I will write all of that and try to write neatly. But if you had a problem, you can always ask me, what did I write? And then I'll post the video, the recording of the class also. So usually it takes me a few hours because I go home, upload them on YouTube, and then upload. So usually by the night you have them, all right? And sometimes earlier. All right, any question on strategies, how things work in the class before I go to actually the course, like our first topic today? Nothing? All right, it's 3:20, we are here in Twitter. All right, I'll give you 5 minutes. In 5 minutes, in this 5 minutes, I want you to talk to the person next to you, right, left, or behind you. Introduce yourself, ask them their name, what their subject is, what their hobbies are. Okay, use 5 minutes, and then we come back after 5 minutes. All right. Oh, Brazil was great.
Yeah.
So I'm gonna pause this recording, but remind me to. I'll do that after class. All right, everyone. That was your time. Okay, I hope that you get to know your class a little bit. Do the discussion board, comment discussion board, and try to really write the way that you're actually trying to know people, talk about yourself rather than doing an assignment. It's not an assignment. Like I made an assignment to give you some point for it and make sure everyone does it. But this is your introduction to the class and something that we keep in the repository, right? So if I forgot your name or what you like to do, I can just go to Carmen and like, oh, I remember now. It happens, like, you know, sometimes I ask your name, you ask my name, and then 5 minutes later, oh, what was that? I forgot. the discussion board is a very good place to remember all of that, right? So try to do it sooner rather than later and really talk about yourself. And if you're recording a video, you get extra point. And also we'll hear your voice. Make sure you don't have a mask if you want to put your picture so we can actually see your face because we cannot see each other's face. All right, so back to our topic today, which is control theory and why should we learn it? So just a quick reminder or kind of a notice, if you had robotic with me, you have heard about some of the control stuff. If you have had some sort of control before, you know, in other project, other courses, some of these sounds familiar to you, just bear with us, be patient, and good for you, you will do the assignments better. Okay, always think of that. I'm ahead of everybody else. All right. I have to assume that you are not familiar with these topics. You have to start from the fundamentals. All right. So control systems. All the mechanism that helps us to alter the future of a state of a system. Now, what's the state of a system? What is a system? Let's go back. What is a system? Yes. Yes. Anything that will receive an input and give us some sort of output is a system, right? Now, when we're talking about a state of a system, we are talking about a very specific behavior thing in the system that we can follow and see the changes, right? And we can alter that. Let's say you're going from point A to point B, and the position of you will be the state. The velocity of you also would be the state. These two are different, two different states. Manipulating one would affect the other one, but you can study one individually, right? Starting from initial condition, everything's 0, you get to a point, this is your final position, and we can check the state of you, car, robot, satellite at every time in that, the position, that is state, right? So that would be the state. Now we can manipulate this by changing some sort of input. So if this was a car, if you accelerate or increase the speed, the position will change, right? So the input will be changing the speed. How do you change the speed in a car? Press the pedal, right? So you're altering, you're manipulating, and then your position will change, but your velocity, speed here also will change, right? So that's what we talk about when we say state. That's one specification of a system, that one specific thing. Now, the goal here is how do I change the input of my system to get an output which I desire? How many of you have watched Lucifer? What's your desire, right? So how can I change an input to get you what you desire? That is a control problem. That's what we're trying to solve here. Now, when we say control, it means that something that is purposefully is not just a change in the system, it's something that we can actually track and change and control. We have control on, right? So to get to that desired state. Control system, control theory is that the strategy. How do I do that? The how do I do is the control strategy. And you might have heard control law. That's basically what we want to get to. What's the law? What's the control law? What's the strategy that if I give certain input, I can get my desired output, right? So that is it. That's it. That's the whole thing. Now, how do we do that? Become this course and the course after that, 5551 and other control courses. Basically figuring out this law. The fundamentals are easy. Now, figuring out what that system is, that's also part of the problem. It's not a pure control problem, but it's part of a problem, right? Some of you are here because you like control. Some of you are here, you like robotics. Some of you are RF person. Some of you are electrical engineers that you want to do nothing to do with control appearance, like on the surface. But the thing is, anytime we have a system, we have to control it, right? The input output. Now it could appear in electrical, like in switching regulator. It could be in satellite. communication and control of what is the gain that I can act like use for like tune my satellite to get some signals, attenuate them, or whatever, do that, or a more clear and like visible use of application of control in robotics. How do I control this arm to go from this point to pick up that object with this velocity that I desire, right? So regardless of what is your field, control can help you or give you an understanding how the system around you works. And if you're in a company working with someone, you're purely like a power person, you're calculating power, you have to take this course because then you can graduate, right? Worst case scenario. But your colleague is a control person. You will understand their language. You know how to talk to them. When they say, talk about input, output, PID controller, tuning something, you would know what they mean. That would be enough of a goal for you to have for this course. So in the class, I think pre-survey class, I asked you what's your goal? And I want you to really think about what you want to get from this course, because anybody can take something different from the course. Really depends on you. If your goal is, I want to be the graduate, be it. That's a good goal. You can graduate, go get, just make money. If your goal is, I want to maybe work with robotic system, I need to understand how to control them. Also a good goal, right? So again, when you're doing this survey, don't just do an assignment. Think about, this is a good chance for you to think, what do you want from this classroom? Now, how many of you have driven a car? How many of you have been in a car? Hopefully everyone. Okay. So if you think about car as a system, as a big system, the car has a smaller system in it, right? Can you name some of those smaller subsystems? That's what we call them. You can also cheat this time. Yes.
Like a transmission or something?
Transmission. What else? Cruise control system. What else? Steering. What else? Have you been angry at someone? Give them highlights. Like the whole lighting system, right? So there's so many systems, braking system. There's so many subsystems, but they're also that you could divide them in a smaller system until you get to a really small or just a component level, like headlight. You can't go simpler than that. But if you come up, it will be headlight and the circuit. You come up, it will be the headlight connected to other light connected to like a controller that you can like the lever and everything, right? So as you go up, you see the bigger picture, the bigger system, and you can scale down until you get to component level, right? So system level, subsystem, and component level. So the system is collection of all these interconnected parts. Now, when we are analyzing a system, when we are in this class, when you're dealing with control, it is really important that we know what system we are analyzing. So it's not enough to say I'm analyzing this car. No, you have to be specific. Are you checking analyzing the brake? This brakes, the brake system, the transmission, the cruise control, all of those can have part in that. But you would need to really understand what your system is, because part of control is to write down the dynamic of the system. Now, if you don't isolate that system, you'll end up with something really big and complicated that you really don't care about controlling anything in that. You're just working on a small piece. That's why we will start with block diagram and try to figure out like what that exact system is. It will look simple. You have had it in, I think, 30, 50 signal and system, but it is needed to understand what actually is. All right. We talked about system has input, has output. Now you can have a simple system, single input, single output, right? Like a hydraulic force, you have that brake system and the rotor temperature. That's one thing that you are trying to, if the temperature regulation is something that you're trying to figure out, then this will be your system. It will look like this. Now, the car as a whole system is a complex system, could have multiple input and multiple output. We are not working on the MIMO system, multiple input, multiple output. You only focus. So every time you will find one state or one characteristic, and then figure out what input can impact our system to get us that one output desire. All right. When you get a problem from me, it is your kind of responsibility to understand what is it I'm actually analyzing here. All right. So I believe in critical thinking and problem solving. I don't believe in giving you instructions, step 1, 2, 3, 4, 5, follow this, and then give you the final answer, you'll be good. I think university is where you have to develop this ability to be able to think for yourself and understand, okay, what is it the problem that I need to solve? Defining the problem is important. Once you have the problem, you have the solution already. We have 3 kind of problems when we're dealing with systems, right? Sometimes we have the input, we have the output, we have this fantastic robot. We know if I push this button or I move this 3 centimeter, this arm moves this much. So I know the input, I know the output, but I don't know what's the dynamic. I don't know what the system is. All right. If this is your problem that I want to model the system, then your problem is system identification problem. Again, it's really important you understand what kind of problem you have. If you have the input, you have the system, you know what the dynamic, when I say you have the system, it means that you have the dynamic, right? Right? When you have the dynamic, you have the input, but you don't know what the output is. What would you do usually? You simulate that, right? You build the simulation in MATLAB or any software, you give the input, you get an output, you change the input, you different output, right? That will be your simulation problem. The third problem is you have the system, you have the car. Your desired state is to go 89 miles per hour. You need to figure out what's your input, how much you have to push the pedal, right? Let's say you're not using cruise control yet. You haven't gotten to that speed. You don't know what the input is to get to the desired output. That is control problem. Now, the thing is, our problems are not, most situation is not as easy as, okay, I have my system, I know what output I want to get. Let's see what input it is. Usually we have a desired state. We don't know what our system dynamic is, and we also don't know what output gives us that system dynamic. What do you think we should do in that scenario? Which is really real life scenario. What's your name? Okay. What would we do in this scenario? So we know the output, we have a design. Usually when we are facing a real life scenario problem, you have a desired output. You know what your system wants. But you know the system is a car, but you don't know the equation, the dynamic. You also don't know what input gives you that output. What do you think? What do you think you should do to solve this problem? Okay, good. So how? Good. That's very good. So this is the critical thinking problem, right? So you know there are 3 different kind of problems, and that's it. Now I introduce your problem that is none of that. So one way and one thing that you would do in control is I know what my output is going to look like. I also have access to output, right? So what James, right, suggests is that how about we input something that we know and we take a look at the output, then input again, take a look at the output. So we have input and output. What is missing? Which problem now we have? System identification, right? So we identify our system, and then now we can go back to, okay, I have my desired actual output. I identify a system that could work. Now I have a control problem. So you'll see that a lot of input signal, step input, impulse input, you have like a stair type kind input. Those are real familiar and inputs that you can build, and always look at your output. And that way you can identify what kind of system you have. There's also direct derivation of the system model, right? You simplify, you create a model, then you say that, okay, so you identify the model, right? So that was the identification problem. Then you go and try to solve control problem. Now you put an input, you have a system, the output is not what you wanted. Because your model is probably not accurate, right? What should you do? What problem is that you have now? What's the problem that you're having? What problem? We did the system identity. We estimated a model for a system, either through direct derivation or through the methods that exist using like literally system identification method in MATLAB. So we did that part. What's the next thing? The simulation. So we estimated our model. We say, okay, now let's give input and look at our output. Does it look like what I wanted? No, let's run 10 times, 15 times, 100 times. And then you might have to adjust your model, right? A lot of time because we linearize, we simplify, we have to adjust. That's how we find out adjustments. Once we are happy, then it's like, okay, I kind of get what I wanted out of this. I adjusted my system. Now, what input exactly gave me that? And that becomes your control problem. You write your control law based on that. So you see that there is not just one step solution. You have to iterate, go between back and forth. What's your question?
I was just going to say, it's just that if you're trying to get across your iterate process.
Yes. Yes. Sometimes it's easy. You have a DC motor. You can drive the equation just by looking, simplifying, and then you just adjust a few things, and that's it. Sometimes, no, it's not as simple. Like it's an underwater vehicle you built with your team. Everybody had an idea. The night they came up with a new idea. You build it. Nobody knows the model. What you have to do is test, keep updating the model. Test, updating the model until you're happy. Then you say, now I want to go with this velocity. What input takes that? Gets me that velocity. So it really depends on the complexity of your problem. It could be a simple problem, it could be complex, but there will be an approach and answer. That approach, that methodology is the control theory. And it's not just the last step, it's all three of them iteratively. So I talked about all of those here. Basically, well, I have to stay here. Going between all of those and usually using a software to help you with simulation. A lot of software have system identification toolbox built in them. So an example, I don't know if you might not have heard, let me go here. So black box problem. So you have an input, you can get an output, you don't know what your system is. That's a black box. You can use the toolbox, like for example, in MATLAB, system identification, you estimate a model that will behave the same way. Now, once you have that model, that black box is a white box because you know what's in it. So you identify, but you have to remember it's an estimate. Usually, if you are answering one of these questions, for example, how can I model something? That's system identification. All right. But if you have, hey, okay, I'm working on this with NASA on this like really like cool airplane or jet or whatever, and we have kind of a system, we have an input. Let's shoot the thing in the space and see what's the output. You don't want to do that, right? You want to simulate in the computer first, make sure everything works, then test. So that is the simulation part. Then you will get to the control part. That's how I get my system to meet this performance requirement. You'll see that I will ask you, we want to have overshoot of this, or we want our rise time be this, or I want my system to get to what I want in this many milliseconds. These are some performance requirements. Then you have a control problem. Because your system works, you know what your system is, you just have to tweak your input to give you that output that is desired. All right. Now, this course could be very easy, could be very difficult. If you look, we already talked about what this course is about. You have three kind of problems, right? And usually you have to use, well, I would say basic math. It just means it's not complicated triple integral or like complicated differential equation, but you'll have to use basic algebra. So if you forgot, you have to refresh yourself. We will use them on daily basis. You have to use some basic trigonometry, not as much, but a little bit when you have actual mechanical system. Then you have to use calculus to some level. But all of this seems simple, right? So if the math is simple, If the system, like we know what the problem is, the goal is to develop the control law. What's the problem? A lot of people have problems with control, the concept, right? The system. If you don't identify the system properly, if you don't define the problem properly, if you don't know what states you're tracking, then you can't find the solution, even though you have all the tools. So every time you come across a question, assignment, homework, you're reading the textbook, you have to understand what's the system, what am I being asked, what is the problem. If this is defined wrong, then it just wastes up time 1 to 2 hours, you will not get it. So my suggestion is when I'm solving a problem, follow my procedure, the steps I take, what do I do to help you build this critical thing, like just with James, right? And it's okay if you don't know it. You know that you have I will give you the information you need. You just have to play with it, right? So go through this process. At the beginning is harder, but as you go and you get used to it, becomes easier. All right. So things that you have to do is to to write your discussion board, introduce yourself, to do the pre-class survey. Does that need a code? I think you might need a code. Let me get there. Or not. I think I might have done it, made it free for this class. Yeah, no code. So do those two. I will see you on Wednesday. We will actually start control the LTI system on Wednesday, and you will start doing class participation and some quizzes. All right. Right. See you on Wednesday.